everyone, welcome back to Decode with Sahil. So today we are going to solve the problem maximum subarray. So it is basically one of the most common and important array problems in coding interviews. Like this problem introduces an amazing algorithm called Kadane algorithm, which we'll discuss. Okay, and it is a key to solve many other optimization problems efficiently. Okay, so let's get started with this problem. So about this problem, that it says that you are given an integer array nums, find the contiguous subarray. Okay, so basically you need to find the subarray, okay, with the largest sum and uh, return its sum. Okay, so basically what do you understand by the term subarray? Subarray means the portion of the array which is there in continuation. Like this is a subarray, this is a subarray, but minus 3, minus 1, 2, this is not considered a subarray. You need a continuous portion of the array. Okay, so now uh, we need to return the subarray with the largest sum. Okay, so if we consider this first example, so what is the largest subarray? So as you can see in the answer, that minus 4, 4 minus 1, 2 and 1. So this results in a total of 6, which is the largest sum of this subarray. And like if we try 2, 1, minus 5 and 4, so it will be 2. So, yep. So this way we have to find the largest subarray and return our answer. Okay. And there's a follow-up, so always try to go down to the problem and try to see what they are asking. So uh, they are saying if you have figured out big of n solution, try coding another solution using the divide and conquer approach, which is more certain. Okay, but firstly we have to do the solution in big of n time complexity. Okay, so you guys can think of the solution and then again play the video. Uh, so what we can do is, so always, like as we are discussing about, we should think of a naive approach and then we'll try to optimize it from there. Okay, so now what will be the brute force approach that will come onto your mind? So what you will do, so then you will iterate through all possible subarrays in the array. Okay, so all possible subarrays means, so the individual elements are also subarrays. So minus 2, 1, minus 3, 4, these individually also form a subarray, right? Combination of two elements, minus 2, 1, 1, minus 3, minus 3, 4, this is also a subarray. Then combination of three elements, minus 2, 1, 3, 1, minus 3, 4, this is also a subarray, right? So this way you take out all the possible combinations of subarray, take the sum of the subarray, and then calculate the maximum and return the maximum subarray from all of this. So uh, this is a way to solve the problem. Okay, but this approach will work, right? But what you have to do is you have to compute all the subarrays and you have to store the result as well and compare it. So this has a time complexity of n square because you are iterating over the array twice. Okay, because you'll be doing a nested loops to generate the subarrays, and this is inefficient. Like it could be an efficient way to solve the problem if the array size is small, but if, since it is given that the array size is pretty large, so this approach would fail for large outputs. Okay, so we need to optimize the approach. So now there's an algorithm that is called Kadane algorithm, right? That is specifically developed for this kind of problem. So this can be used to solve this problem in n-time complexity. Okay, so now what what we can do is that we'll iterate over the array and we'll maintain the running sum. So we'll maintain the running sum, and whenever the running sum will become negative, that time we know, right, that if the running sum becomes negative, then that portion would not contribute to the larger subarray, right? That portion would contribute negatively to the subarray, but we want a positive contribution from the subarray, right? So in that case, we would reset the current sum to 0, and similarly, we do this for all of this, and then we'll keep on comparing the current sum with the maximum sum. So this way, uh, after the iteration of the whole array, we are there with the maximum subarray answer. Okay, so let's code the solution so that you would understand it better. Okay, so what I'll do is uh, I'll take a max sum variable. All right, so I'll be assigning it to a minimum value. Why minimum value? Because if I'm comparing it with a value, so it should be like if I am comparing it with a negative value or say 1, so it should be a minimum value to be compared with so that it would be assigned as a maximum value, right? And I'll take the running sum as a variable current sum and I'll assign it to 0. Running sum is 0 initially, right? Now I'll do a for each loop, right? And now uh, I'll always add the element to the current to the running sum. So what? So the current sum would be, so now suppose we started from here. Okay, now the current sum is 0. Now minus 2 comes, so the current sum would become minus 2, right? So this way we are going to increment the current sum, and we are also going to check the maximum sum, like if maximum sum is greater or the current sum is greater, whichever is greater, we'll modify that. So we'll modify the maximum sum as maximum equal to math.max max sum comma current sum, right? Right. So we are going to compare it at every iteration, the maximum sum and the current sum, so that whenever max sum value is greater than the current sum, it would take its place. Okay. And if the current sum, it's if it's less than 0, if it's negative, then it don't contribute to our uh, maximum sum, right? Because we need a positive sum, so we'll reset it to 0, right? And and we can return the maximum sum, which is our answer, because the maximum sum contains the answer. So you see, it's a pretty easy problem. uh, I'll just run this problem so that we'll see for any issues. Okay, so the base cases are accepted. All right, so uh, it is running fine, and it is an optimal solution also. So the time complexity of this solution, as you can see, that we are iterating over the whole array only once, so the time complexity would be big O of n, right? So this is the Kadane algorithm is a very popular algorithm. You can try it yourself, and this can be used in some other problems as well where you need some kind of optimization. So thank you so much. I'll see you in the next video.